This is Anita Wood, and welcome to this topic snippet video that describes a technology used by many organizations, cloud computing. Cloud computing has become a buzzworthy topic for today's technology, driven mainly by the predominant organizations who offer the services, like Google, IBM, and Amazon. Cloud computing is the next technology to bring the internet to the next level. If we just spend a few seconds thinking about the history of the internet from a consumer's perspective, initially the internet provided us with the ability to search for information that was located on what I'm calling static pages. These pages did not do much. They just showed us text and pictures. Email was soon added to the internet's capability, followed by more interactive web pages that actually allowed us to push buttons, complete forms, and send emails right from the site. Some people may remember when the internet was not an extension of your TV or movie theater, but streaming did not always exist on the internet. Neither did its use as the shopping mall of the world. We discussed how online repositories have changed software development, and now we have the cloud. Soon, you'll see it's not new. It just started to enter the vernacular of our everyday life. For some people, cloud computing is a big deal, but it really isn't. In reality, cloud computing is something that we have been using for a long time. It's the internet facility, along with a couple associated standards that provide a set of web services to users. When users interchange the term internet for a cloud, they're not really too far off. The internet does represent the essential characteristics of cloud computing. No internet, no cloud. When the dinosaurs roamed, small companies with extensive IT followed the old traditions of managing their own IT infrastructure. For example, we called that the server room. The server room consisted of database servers, mail servers, firewalls, routers, switches, and other networking devices, along with the personnel or server engineers. To provide and support such IT infrastructure was a huge amount of money. So, to reduce the IT infrastructure cost, IT computing technology came into play. The concept of cloud came into existence in the year 1950 with the implementation of mainframe computers that were accessible through thinner static clients. That just means those dumb terminals. Since then, cloud computing has evolved from static clients to dynamic ones, and from software to services. The following diagram explains the evolution of cloud computing. In the early era of technology, client-server architecture was popular with mainframe and terminal applications. That means we had a mainframe computer, one main computer, and there were a lot of these client terminals accessing one computer. And those terminals, all they did was provide us with a monitor and a keyboard. No logic, no capabilities. Everything resided on the mainframe. At that time, storing data in CPU was very expensive, and hence the mainframe connected both types of resources and served them out to those little terminals. With the revolution of mass storage, file servers gained popularity for storing vast amounts of information. In the 1990s, a giant connecting concept, the internet, finally got enough computers attached to it. The connection of those machines together creates a massive, interconnected, shared pool of storage that wouldn't be possible for a single organization or institution to afford. There comes the concept of grid. The term grid has a misrepresentation as a synonym for cloud computing, as both of the technologies is formed by many computers connected. But grid computing requires the usage of application programs to divide one large system processing into several thousand machines. But there's lots of disadvantage. And if a single part of the software node fails the processing or working, other pieces of the software node will also fail. So this grid-based working concept didn't become so fruitful. Now, on the other hand, cloud computing involves the concept of grid, except that it provides the demand resource provisioning. On the first milestone of cloud technology, Salesforce.com engraved its name in 1999. It pioneered the technique of delivering enterprise applications through a simple website. They provided both specialist and mainstream software firms to bring up and use over the internet. The next development was in 2002 when Amazon stepped in with their web services, and you may have heard them as AWS. They provide cloud-oriented services, which meant they had storage, computing power, and human intelligence using something called the Amazon Mechanical Turk. Think about the movie Big. In 2006, Amazon launched their EC2, or Elastic Compute Cloud. It was a commercial web service that let small organizations or even sole proprietors to rent computers on which they ran their own computer applications. EC2/S3 was what it started extended to, and it was cloud technology infrastructure services. People now got to use servers and other people's computers. In 2009, another significant milestone engraved the name of Google with Web 2.0. Google and others started to offer browser-based applications via Google Apps and other apps. Then came Microsoft's Azure. Both Microsoft and Google deliver services in a way that are reliable and easy to consume. Let us assume that you're CEO of an organization and you have a big organization. Naturally, it becomes your duty to ensure that all the employees of your organization have adequate hardware and software to carry out their tasks. Now, it's not possible to buy software and applications for every computer and every employee. As the hiring of the employees continues, the buying of licensed products is also mandatory. So you have to spend a lot of money on each employee. But there's an alternative concept you can execute for better results. Instead of buying and installing software on each PC, load a single application that will allow the employees to log in to a web-based resource that hosts all the user's programs based on requirements. Everything will run by other companies' remote servers and facilitates us by providing everything from word processing applications to spreadsheets, database applications, email, data analytics. Think of Google. And the technology I'm describing is called cloud computing. Okay? Cloud computing brings a shift in the real paradigm of technology in the way that systems are deployed. The massive cloud computing technology was enabled by the likeness and trends of the internet and the growth of some famous multinational companies. Cloud computing makes the user's dream come true in reality by the concept of pay-as-you-go. Infinite scale architecture, meaning I can go forever and make it as big as I want. And high speed and accuracy. With the cloud's help, an individual or an organization can now start from very low and small and get big with a short amount of time. Cloud computing is said to be the revolutionary change. Even though the technology is still evolving, we don't know what it's going to be tomorrow. It takes services, applications, and technology similar to the internet world and converts them into something called a self-service utility. Cloud computing is this latest and greatest technology, okay? And it provides us a means to use these applications as utilities via the internet. Makes IT along with its services available when I need it. The technology, it's a development platform, hard disk, computing power, software applications, and database, as I already said. And it doesn't really involve large-scale capital expenditures, meaning purchases of technology for us to access. Instead, this pay-as-I-use, the users just pay what they need for an unlimited amount of use. So as my need changes, so will my pay, and so will my ability. The cloud is divided into different layers, and these layers are the front end and back end. The front end is the part of the cloud which the user can interact with. For example, we log into Gmail. We see the UI, or user interface, where everything works with buttons and graphics. Similarly, the software also runs on the front end of the cloud. Again, the back end comprises hardware as well as the software that's going to deliver all of the information that's located on the back ends or from databases to the front end or the user. Since cloud technology provides many benefits to the user, these benefits should be classified based on the needs of the user. And that's something that we have and that they have done. It's called deployment model. It represents a category of the cloud environment based on proprietorship, size, access, and also describes the nature and purpose of the cloud. No, not the entire cloud, just the cloud in which this particular deployment is being offered. Most organizations implement cloud infrastructure to minimize the capital expenditure and regulate operating costs. So which deployment model matches your desire and your needs is essential for the user and the learner to understand. And they are public cloud model, which allows systems and services to be easily accessible to the general public. The public cloud is going to be a little less secure because of its openness, because if nothing else, email, which is just, nightmares for those running servers. And it's a type of cloud hosting that easily allows the accessibility of systems and its services to the clients and users. Examples of these are the public cloud facilities that IBM offers, Google, Amazon, and Microsoft. This cloud service is open for use, and it's a true specimen of cloud hosting, where the service providers render service to various clients. The second deployment model is called private cloud model, and it allows systems and services to be accessible within an organization. It offers increased security, unlike the public cloud deployment, because it's private. It also is sometimes termed internal cloud, and it allows the accessibility of systems and services within specific boundaries or a specific organization. The cloud platform is implemented in a more secure environment, guarded by more advanced firewalls, under surveillance of the IT department that belongs to the particular organization. So private clouds permit only authorized users, providing the organization greater control over the data and its security. Another one's called the community cloud, which allows systems and services to be accessible by a group of organizations. And it's another type which will allow for sharing among these different organizations that belong to some of the same community or an area. An example would be a community where the organizations are, along with financial institutions and banks. This setup is developed using clouds among different organizations that belong to the particular group. And many times they have similar computing concerns. So there could be joint business organizations that have a community cloud, a organization that has similarities in computing needs because they're charitable. They could be sharing and using a community cloud. It just knows that the community-based cloud users, they need to know and analyze their business demands first. Hybrid is the final one, and it's a mixture of all this other stuff, okay? It's a mixture of the public and the private. However, the critical activities are performed using the private cloud, while the non-critical activities are pushed and performed in the public cloud, okay? So it's a mix of both. Cloud computing has another way of being divided, and it's based on what kind of service is being provided or being needed. Okay, and there are three types of service models. You have an infrastructure as a service, which sometimes you see as IaaS, platform as a service, which sometimes you'll see as PaaS, and software as a service, SaaS. Now notice, each of these service models inherit the security and management mechanism from the underlying one. And the diagram is important here because you got application at the very top. All right, then you have platform, then you have infrastructure. Thinking about how and what we know about our computer system, we know the infrastructure is the hardware. The platform is all of the various hardware plus the operating system to make that hardware work. And then the applications sit on the top, like Word. Okay? So let's just briefly look at these. Infrastructure as a service is the most basic level of service. It can be a network as a service, business, identity as a service, database as a service, okay? What it is it means you can use this service and you're trying to get a hold of physical machines or virtual machines or some sort of service that you need actual infrastructure for, okay? Then you've got the platform as a service, and it provides a runtime environment for the applications. All right, if I just want the infrastructure and that's all I pay for, I have to provide my own, for instance, operating system. Platform as a service is going to provide those for us. Okay, we're going to get the operating system, which is sometimes called the runtime environment. Finally, you got the software as a service, and now we got software applications that are available to be used and download. Google's got that for us. Okay, think about us using Google, and Microsoft 365 is another one. Now, cloud computing, we had in our discussion mentioned many numerous advantages, and there's a couple more, but ultimately what it's giving us is on-demand, self-service, online development and deployment tools for programming and anything else I need. Okay, it doesn't require me to install software to access or manipulate. It's web-based. I get some increase in computing power, and all I need is this internet connection to get the services that are highly efficient and optimized, because that was what the company sold to me. All right, these servers that I'm accessing have real high capacity for running and processing tasks and processing applications. It's really low cost in infrastructure because the investment's less. I'm going to get cloud storage capability. It's going to be unlimited. Now I can buy and pay as I need, but I mean, I can get up to 2,000 and 3,000 gigabytes and get more based on my requirement. Now to run the technologies, I don't need high-powered computers either, because the application is running out in the cloud, not on my PC. And I actually can reduce my IT staff and those servers engineering because I don't have that much on site anymore. I'm paying for others to take care of the equipment. The software cost is reduced because I minimize it, as I don't have to purchase it for every computer. And not only do I not have to purchase it, I don't have to update it. And if I have more people that come on board, I don't have to pay for all of the licenses for all of those individual computers. Now, cloud computing is promising. It has benefits, but it also comes with risks. One of the most obvious one is you have to have a constant internet connection and internet speed. Now, it's impossible to use cloud infrastructure without the internet. To access any application or your storage, a constant internet connection is required. The speed of your internet service provider has a lot to do with the speed you can access the cloud. So for us living in metropolitan areas, that's not an issue, particularly when you got fiber. However, the rest of us do not have guaranteed speeds, let alone guaranteed uptimes. Security and privacy is an issue, and it's a real big concern, because with cloud computing, all the data is stored in the cloud on somebody else's machine. So make sure when you hear and someone says cloud, even yourself, don't point up, point to somebody else's machine. So with that, then I can have unauthorized users gain access to my data. All right. The data management and the infrastructure management tools are going to be provided by a third party. That's always a risk because I'm handing over some pretty sensitive information sometime to the cloud service providers. Although the cloud computing vendors assure high secure password protection on the accounts, any sign of a security breach could result in a loss of customers and businesses. Lock-in. And what I mean by that is it's really difficult for customers to switch from one service provider to the other. There's a lot of upfront and factoring for me to get my stuff up to one service provider, cloud service provider. So if I'm trying to switch in one aspect, I have to bring it all down to bring it back up again. They're not too friendly on doing transfer to transfer. It's not like the cell phone worlds where let me transfer your phone. I am AT&T. I'll take anybody's. No, it doesn't go like that. Isolation failure is something too. It involves the failure of isolation mechanism that isolation means I'm separating the storage, the memory, and the routing between different tenants, meaning different people on the one drive, all right? And when my customer management, my software interfaces are going to be accessible through the internet. So a breach in the system could be devastating. Again, the other final one is insecure and incomplete data deletion. It's possible that when I'm requesting data to be deleted, it may not. Okay. And it could happen because I have extra copies of data stored and I don't know it because of the backups which they provide me. When I say delete, I'm assuming they remember to delete the backups. That may or may not be within the contract or in somebody's understanding. Okay. And the other side that you could get in trouble with is a disk. Yes, you have multiple backups, but if for some reason you end up, a disk does get destroyed and it contains data with multiple users, and a lot of people are impacted by it. So that concludes the topic snippet on cloud computing.